We have then the idea that there are two kinds of dependencies: narrow dependencies or wider dependencies, where the wide dependencies can involve shuffling data, and this is something we want to try to avoid. So if you've got an awareness of this, then you can build more optimized programs. But it does help to understand the kind of optimization that your code undergoes and why it's being optimized in that way. So they try and pipeline together narrow dependencies and also limit the number of shuffles. So any data extraction should be done before you go through a wider dependencies, and this allows the reuse of caches and so on. So having an awareness of this, the underlying mechanism, will allow you to at least know what the code is doing. So coming on to specifics now, transformations are actions which, in simple terms, it's lazy evaluation, so they don't get evaluated until it's actually needed. So things like map operations, which are essentially loop, group by key, filters, operations like distinct, union and so on, joins, are evaluated lazily because they transform the data set. Whereas actions involve the construction of the directed acyclic graph and hence the code execution. So in other words, these are the steps which appear to do something. So collect is one that you see quite a lot, and essentially this goes round all the workers, collects the data back and brings it back to the master program. So firstly, that's slow, and secondly, there is a risk that you'll run out of memory. So try to avoid doing collect unless you've got to the end of your computation, because essentially you're collecting all the data back from the workers to the master. You can cause an out of memory exception on the master. Count, something we do use a fair amount to see how big a data set is. Of course, this is going to involve really counting everything, bringing results back to the master and so on, is going to be quite slow. So rather than doing count or collect, quite often an operation which can be save time, though it's not doing the same thing, is if you just want to do first, so we'll just collect a number of results, or take. So rather than returning the whole data set, just do take 5, takes the first 5 elements. Going to be a lot quicker than collecting the whole thing together. So those are some things to be aware of. And saving the output as a text file. We will see later on getting output from Spark can be a little intricate, and that's done by save as text file. There are more operations which you'll see cause evaluation to happen, but the default is for evaluation not to happen at that point. Certainly not with the transformations. Just to recap then, in looking at the Spark internals, CPU is fastest. If we've got to move data around a network, that is slowest. Caching data in memory is always handy, and that is going to be faster than storing our data on disks. So you've got a balance going on here. Storing data intermediately in cache, possibly running out of memory, or writing it to disk. You want to try and avoid operations which you see as causing a lot of shuffles. We'll see in week 11 actually you can monitor what operations are doing, what number of shuffles. So that's something to look out for. We've also met the Spark context as the main entry point for Spark functionality. It gives us a connection to the Spark cluster, represented as SC in your code. You'll also see we'll meet later on the variable Spark, depending on how we're initializing things, and we can get from from SC to Spark and so on. But at least SC should be bound in terms of the program. That's the typical view of the Spark driver. We've got our Spark context, we've got the cluster manager there, we've got workers, we've got caches, we've got tasks being executed. That's yellow there, shouldn't be using that because it's very hard to see. Doing that in relation to our Spark PySpark notebook. Talked quite a lot about the RDD, which is the primary underlying abstraction. So even though we might be working at a higher level, RDDs are the fundamental data element going on underneath. Allows us to have parallelism and so on. Maybe persisted in memory. We'll see how to do that later on. And resilient. So if there are node failures, then we can recover from those. So just like quick retrospective onto the Spark architecture, you need to understand RDDs, you need to understand transforms as part of extract transform load. You need to understand what things will cause executions as opposed to transforms. You need to understand that we have delayed execution, so code seems to work. Actually, it's not done anything until you hit the collect, and at that point you find that there was an error 3 or 4 lines before. There'll be a volume of error material generated. This is always a little bit overwhelming, but if you work through and you don't expect that the line where the error shows was the line that caused the error, then you'll soon get to grips with the debugging. Nice to know about what's going on with the scheduling, nice to know what's going on with caches and storage and shuffles, but generally speaking, the advice is don't optimize until everything's working. Once everything's working, you're getting the right results, then you might want to go back and optimize, but be aware of these things. Now, to find out more, very strongly recommend this book, Learning Spark second edition. It's O'Reilly. It's very clear. It's 2020. You get it through the library. So you go to the library website. That's Northumbria Library website. We've got an O'Reilly subscription, and it's compatible with everything we're doing. It's very clear and so on. In terms of the basics, you'll probably still find the first version of Learning Spark is relevant, though given improvements with the optimizer, there's now a general emphasis to prefer Spark SQL over working directly with RDDs. There are obviously other improvements between 2015 and 2020, which are covered in the second book, second edition. Second edition also has examples in Python and Scala. If you know a bit of Python, then it should be fairly clear what the Scala examples are doing. Usually there's both. And this sort of intermediate book here, again available through the library, Learning PySpark, less heavy on the theory side, but again quite useful. I think generally in order, Learning Spark first edition corresponded to Spark 1.5, 1.6. The 2017 book was Spark 2 and the 2020 book is Spark 3. The enhancements better documented in obviously the later edition. Okay, so that's the end of this presentation.